Hello Warriors, this is Miss Lemons, and today we're going to be going over the mole concept. Specifically, we're going from atoms or moles to atoms. I've already created 2 videos prior to this that go from grams to moles or moles to grams. And before we get started, make sure you have this worksheet out, a calculator, and a pencil. If you did not view my other 2 videos about going from grams to moles or moles to grams, please make sure you take some time to view that now. So let's look at question number 13. 13 asks us to determine the number of uranium atoms in 2.020 moles of uranium. We are starting with 2.20 moles of uranium, and we're trying to get to the number of atoms of uranium. So just to kind of keep things color-coded here, I'm starting with 2.02 moles of uranium, which I put here. And I need to get to number of atoms of uranium. So let's determine a conversion factor. The nice thing is that we only have 2 conversion factors to pick from. And remember, our conversion factor needs to contain both of these units, moles and atoms. So here we have moles and grams, or moles and particles. And you might be thinking, wait a second, none of those say moles and atoms. But remember, particles can refer to atoms, ions, molecules, or formula units. So we actually do want to use this conversion factor, Avogadro's number. So we're going to recreate that. You're going to write down exactly what you see. That is 1 mole of, not X, U for uranium, is equal to 6.02 times 10 to the 23rd power atoms of uranium. So now we're going to go ahead and do our setup and solve. You know that you're always going to start with what we know over 1. So that's 2.020 moles of uranium. Notice that I have included both the unit and the element symbol in my dimensional analysis. Remember, dimensional analysis is about converting units. So if you don't have units, we can't see what you're converting from or to. We know that we're going to multiply this by a conversion factor. So what's on top must come down. So if we have moles of uranium on top, we want moles of uranium on the bottom. How many moles of uranium? Look at your conversion factors. 1 mole of uranium. If you use 1/2 of your conversion factor, you want to use the other half of the conversion factor on top. So that would be 6.02 times 10 to the 23rd power atoms of uranium. Now I know I've set this up correctly because moles of uranium on top cancels with moles of uranium on the bottom, and I would be left with atoms, which is what we are trying to get to. So multiply your numerators together, multiply your denominators together, and divide your top and bottom. So that's 2.020 times 6.02 times 10 to the 23rd atoms. That's going to give us 1.21604 times 10 to the 24th. 1 times 1 is 1, and anything divided by 1 is itself, so we can go ahead and round this according to the rules of sig figs. You always want to look at what you started with and round to that many numbers. So we've got 1, 2, 3, 4 significant figures. This is a sandwich 0, that's significant. This is a trailing 0 with a decimal, so that's significant. So that's going to be 4 sig figs. Underline your top 4 placeholders. This is what we're trying to keep. We want to round. In this case, because this is lower than 5, we're going to round down. So it's going to be 1.216 times 10 to the 24th power, and that is atoms of uranium.